Welcome everyone. As we spoke before, staying at home is very important to stay safe, to keep your family safe, and to save your country. As I promised before, I will share numerous videos to ease the burden of staying at home, and I hope you will all benefit from these videos. Today I would like to share part of my expertise in renewable energy. Electricity is very important. It's very vital to ensure human comfort. It's very important into two main sectors that I believe the next step after this coronavirus pandemic will be dominated by industrial and farming. These two sectors are very important to ensure our survival in the future. Electricity is very important for industry. It provides them a power. Power comes at a cost. There's a price. And based on my previous experience in the industry, the electricity bill could form a major burden on the industry. Same for farming. Farming, when they do irrigations, they do other stuff. Farming required electricity, required power. Either rely on diesel, which could cost a lot of money, or they can now use the advanced technology in renewable energy. Today, we are going to focus on the inverter, and we are going to start step by step. We are going to go from residential property, follow up by, in the future, we go into industrial system, we go into farming system. So let's start today with house system, PV solar system for housing. We don't want to spend a lot of time. We don't want to make the video too long. Let's make it short by talking about the main component and focus on the inverter, how to size your inverter and how to choose your inverter. Let's start. For a house, let's assume you are going to do a hybrid system or a standalone or a grid connected with a hybrid system. So I need a PV panels. I need panels. We'll go down to a inverter. This is known as hybrid inverter. This will go down to an energy storage. This is your load. If you want to have a grid, this could be a grid. This could be the grid. Today we are going to focus on the inverter. How do we choose the inverter? And what characteristic the inverter should have to make sure my system is superior? The component panels will harvest the solar energy, convert it to a direct current, DC, take it to the inverter. This hybrid inverter has a role to charge your energy storage, to make it safe, and then also to talk to the grid, give or take from the grid, and then to supply your load. What's the most important element for my hybrid inverter? What element I should make sure my inverter has? Number one, I need to make sure my inverter has MPPT inside. The MPPT will make sure maximum power point tracker. It will track the maximum power point of your panels. You can have one said pulse width modulation. It's not advanced as MPPT. So use a inverter, ask for an inverter or hybrid inverter that has an MPPT. That's one element. Okay, that's one element. Number two element, the inverter govern the battery performance and its life. The energy storage, the battery life is a cycle. So every time I fully discharge the battery and charge it. That's one cycle. The energy storage life is cycle. So for example, if my system live 1,000 cycle, that means I can discharge it 1,000 times and charge it. Other than, it will die. That's its life. If its life is 1,000 cycle. The inverter also can go beyond this and protect this energy storage. The battery, depending on the type, if you have a lead acid, if you discharge more than 50% of it, or you make it full empty, you will damage it. And also, if you overcharge or you over discharge, you will damage your battery. That's why this system, you should buy an inverter where it has an option. Make sure no overcharge occur on the batteries. So you should buy an inverter where I can set maximum charging voltage. Also, I should make sure that my inverter has an option that if my voltage of the battery drop below certain value, it will isolate the batteries to protect the batteries. That's why it's very important for me. It's very, very important. Also, your inverter should have an option, if you are connected to the grid, that if you have sufficient solar, there is no need to take from the grid. And also, you should have an option when to charge the battery using the grid. There's no need, for example, in summer at all, to charge the battery using the grid. There's no point. I'm talking in an area where there's irregular power outages. I hope that's clear. So now the inverter play an important role to extend the life of my battery by make sure the battery is not overcharged, not over discharged. Okay, this is very important for me. I need to make sure my hybrid system, my hybrid inverter has an MPPT to harvest the maximum power. I need to make sure my inverter has a ability to see when do I use my grid, when I don't use my grid, during the daytime. Okay, if the sun is not available, of course, your preference to use the grid if for a country that have irregular power outages, for example. Now, what are the parameters of my inverter? How do I make sure to choose my inverter? So the inverter will have a parameters. I need to make sure what are these parameters. The inverter will have a power or maximum power, will have number of MPPT, will have maximum voltage, and will have a maximum input current. So number one is number of MPPT. I need to check, is my inverter has 1 MPPT, 2 MPPT, 3, 4, how many input of MPPT do I have? Each MPPT, as we explained, it makes sure that the number of PV that connected to this MPPT will harvest the maximum power from the photovoltaic system. Okay, maximum voltage. For example, let me give you an example. If V open circuit is equal to, for example, 500 volt, I need to make sure that my open voltage of my panels that connected to this terminal never exceed 500 volt under VOC of my panels. This is very important. Maximum current. If I have multiple panels connected in parallel to this terminal, I need to make sure that, let's say, N multiplied by I of short circuit of the PV panels always smaller than the maximum current of my inverter. N is number of panels in parallel connected in parallel. I short circuit is the PV panel short circuit current. This is very important for me to protect my inverter. So I want to know, how do I size my inverter based on my PV? Let's assume I have 11 panels. I have 11 panels of 360 watt. I have that panel V open circuit, figure of speech, 40 volt, VMPP, it's equal to 36 volt. We haven't spoke yet about the VMPP of the inverter. We're gonna come to it soon. So now I have an inverter. I have a hybrid inverter with, for example, V open circuit, or V max. As we said, for V max. V max is, for example, equal to 90 volt. V max is 90 volt. Okay, perfect. So now to this system, let's say this is a 4000 watt inverter. For this system, I can only install 10 panels. I can only install 10 panels on the condition, this is, let's say, our short circuit, it's 8 amps. Or 9.6 amps. This in here, I have Imax, let's assume 50 amps. So now what can I do is, I can make sure that only 2 panels in series. So for this system in here, I have to connect like this. This is PV panels like this. That's 8, 9, and 10. This voltage VOC will be equal to 80 volt, which is less than 90. The total power is 10 times 360, that's a 36 watt, 3600 watt. And you have 5 times 9.6, less than 50 amps. So I cannot install the 11. If I go ahead and I put one more in here, I will cause a problem, because now in my MPPT now will have different voltages. Is that clear? How do I choose the parameters of my PV panels and my inverters to suit? I hope that's clear, guys. I hope that first lesson teach us that the inverter should have certain criteria to protect my battery. And then if I need to be able to read this. Now, one more item. Every inverter has a voltage, operating voltage. Which is known as a VMPPT range. For example, the VMPP range will be, let's assume, for example, for this one will be between 40 to 80 volt. For example, these two, say, look, 36, so 72 volt still work. I need to make sure that also this V open circuit and VMPP is between the actual operating voltage. I need to make sure that this layout, this VMPP, located within the operating voltage of the inverter. And also every inverter will give you the VMPPT of it. That's why I need to aim for this. I hope that's clear. I hope that links the inverter data to your panels data available, and how do I choose the number of panels. So this, in this case, I have one panels I cannot use, has to stay out. Is that clear? I hope that's clear. Let's